Good morning students, this is Latif sir. In this video today I'll discuss about types of mixture and how to separate the components of a mixture. Okay, so first see formation of mixture. Last day I have discussed in last video I have discussed what is element, what is compound, what is a mixture. Okay, and today in this video I'm discussing about mixture and how to separate the component of mixture and type of mixture. So formation of mixture is the first topic. Define type of mixture. Okay, so different substances in different state may form a mixture. For example, solid mixture. Solid mixture means mixture of two solid. For example, small stone in grains of rice or dal. Alloy is a mixture. Okay, these are alloy is a mixture of two different metals. So these are solid mixture. Stone in grains of rice, alloy, these are solid mixture. Next type of mixture is solid in liquid mixture. Solid in liquid mixture. First one is solid mixture. Second one is solid in liquid. For example, salt water mixture. Sugar water, salt water, sand water. These are solid in liquid mixture. Third type of mixture, solid in gas, that is solid gas mixture. Solid gas mixture. Smoke is one type of solid in gas mixture. In smoke, it has minute dust particles suspended in gases, so it is a solid in gas mixture. Next type of mixture is liquid in liquid mixture. Mixture of two liquid, mixture of kerosene and petrol, mixture of alcohol and water. Okay, these are liquid mixture. Gas liquid mixture. Gas liquid mixture, for example, carbon dioxide gas dissolved in water in soft drinks. Okay, similarly oxygen dissolved in natural water, ammonium hydroxide solution. So these are gas in liquid mixture. Okay, next type of mixture, gas in gas. Air is a mixture of different gases. So gas in gas mixture, air is a air. Example is air or natural gas or hydrogen and oxygen gas mixture. So based on the physical state of different substances, mixture are different type. solid liquid, solid gas, liquid gas, or gas in gas. Okay, now see classification of mixture. Classification of mixture. Mixture are two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. So first I will discuss about homogeneous mixture. A homogeneous mixture is a mixture in which the components are distributed uniformly throughout. Okay, I have highlighted this term uniformly, means equally. Okay, so homogeneous mixture is a mixture in which the components of the mixture are distributed uniformly throughout the mixture, and its components are not clearly visible and cannot be identified individually. And these mixtures are found in the form of solution and alloy. So in homogeneous mixture, a mixture of homogeneous mixture is a mixture in which the components are distributed uniformly throughout the mixture and its component cannot be visible clearly. Now see example of homogeneous mixture. First example is solution. Solution is a homogeneous mixture. A solution is a homogeneous mixture formed when a solute gets completely dissolved in a solvent. When a solute gets completely dissolved in a solvent. For example, mixture of glucose in water. Mixture of glucose in water. Mixture of acid in water. lime water, all these are solution and these are homogeneous mixture. Okay, a solution is a homogeneous mixture in which the solid gets completely dissolved in the solvent. And next type of homogeneous mixture is alloy. What is an alloy? Alloy is a homogeneous mixture. Alloy is a homogeneous mixture of a metal with a non-metal. Alloy is a homogeneous mixture of a metal with another metal or with another non-metal. Okay. So alloy is a homogeneous mixture of a metal with another metal or a non-metal. For example, stainless steel is an alloy. Stainless steel is an alloy of iron, carbon, which is non-metal, and nichrome. Nichrome is an alloy of metal, nickel, and chromium. Okay. So alloy is a mixture of two metal, or alloy is a mixture of a metal with another metal. Okay, example of alloy, stainless steel or nichrome. Okay, these are example of alloy. An alloy is a homogeneous mixture, remember that. Next type of mixture is heterogeneous mixture. Heterogeneous mixture. So what is a heterogeneous mixture? It is a mixture in which the components are distributed non-uniformly. Means not equally mixed. Okay, the components are not mixed equally throughout the mixture. So a heterogeneous mixture is a mixture in which the components are distributed non-uniformly throughout the mixture. And in such case, that is in case of heterogeneous mixture, the particles can be clearly visible. Okay, so the component of such a mixture may even be clearly visible, and they can be identified individually. Now example of heterogeneous mixture, a mixture of soil and iron fillings is a heterogeneous mixture. A mixture of chalk powder in water, it is a heterogeneous mixture. Okay, and heterogeneous mixture are usually found in the form of suspension and colloids. So first I'll discuss about suspension. What is a suspension? Suspension is a heterogeneous mixture. Suspension is a heterogeneous mixture. It is a heterogeneous mixture of a visible solid component insoluble in another component, of a visible solid component insoluble in another component, and it has sufficiently large insoluble solid particles visible to unaided eyes as freely suspended particles in the solvent. And if we left undisturbed any suspension, the particles of suspension settle down. Okay, the particles of suspension will settle down if we left undisturbed any suspension. And in suspension the particles are very large and they are insoluble in solvent. Unlike solution, the suspension, the particles do not dissolve. Unlike solution, in suspension the particles do not dissolve and remain unequally suspended throughout the mixture. For example, now see example of suspension. Sand in water is a suspension in which the sand particle can be seen clearly suspended in water, and if left undisturbed for a while, the solid particles settle as sediment. Now see next type of heterogeneous solution, which is colloid. Colloid is a heterogeneous mixture. Colloid is a heterogeneous mixture in which very small insoluble particles. The particles of colloids are smaller than suspension but larger than or bigger than particles of solution. Okay, so it is written that a colloid is a heterogeneous mixture in which very small insoluble particles which are bigger than particles of solution but smaller than those of a suspension. Okay, so colloid is a heterogeneous mixture of in which very small particles are suspended or distributed evenly as dispersed phase in another component which is called dispersion medium. Okay, so in colloid the particles which are distributed or which are suspended are known as dispersed phase, and the in which solvent the particles are suspended is known as dispersing medium. Hence, a colloid has dispersed phase and dispersion medium. Although colloidal solutions are generally heterogeneous, they may appear as homogeneous mixture as well. Okay. Now see a characteristic of colloid. Like suspension, the particles of colloid also do not dissolve. Like suspension, the particles of colloid also do not dissolve, and they remain dispersed throughout the mixture. However, the size of particles of colloid being much smaller and are not visible, the particles of colloid are not visible with unaided eyes like solution, and they do not settle down even if they are left unaided, undisturbed. Okay, this is the difference between colloid and suspension. The particles of suspension can be easily settle down, but particles of colloid cannot be or particles of colloid do not settle down even if they are left undisturbed, and particles of suspension can be visible with unaided eyes, but particles of colloids are not visible with unaided eyes. Okay, so there's a difference between particles and there's a difference between colloid and suspension, although both are heterogeneous solution. Now see example of colloid: clouds, fog, mist, smoke, jelly. These are example of colloid. A very common type of colloid is emulsion. Emulsion is a common type of colloid, and emulsion is a mixture of two or more normally insoluble liquid. You have to remember the term what is emulsion. Emulsion is a mixture of two or more liquid. Emulsion is a mixture of two or more insoluble liquids. Okay. Now example of emulsion: mixture of oil in water is an emulsion. Oil and water mixture is known as emulsion, is an example of emulsion. Okay, so oil like vegetable oil or kerosene and water form an emulsion when mixed together. Milk is an emulsion colloid of fats dispersed in water. Cream, butter, toothpaste, egg yolk, and all these are example of some colloid emulsion. Okay, emulsion are also one type of colloid. Okay, now see separation techniques. How to separate a mixture and what is the reason for separation. Okay, why separation is important. So see this topic is separation of components of a mixture. Okay, so what is the reason for separation? Here some reason is given. The reason for separation of components of a mixture: to remove the impurity that are harmful and undesirable. Separation is important because uh, to remove impurities that are harmful and undesirable. Okay, and to obtain a useful components, and the third reason of separation is to obtain a pure sample of a substance, Now see different methods of separation of a mixture. Some methods of separation of a mixture. Okay, there are many methods, and each method has a particular principle of separation. So the first type of separation method is hand picking, and principle of separation, differentiating property based on special differentiating property of the component of a mixture. So in hand picking, the principle of separation is that difference in physical appearance of the component, such as shape, color and size. An example is separation of stone from grains of rice. Second method of separation is sievings. The principle of sievings is that difference in size of the component of a mixture. And example of sievings: separation of sand from gravels at construction site. And next method is winnowing. Is the principle of winnowing is difference in weight of the components. An example is separation of chaff or lighter from grains like wheat or rice. Next method is sedimentation and decantation. The principle is difference in weight and solubility of the components. One component is heavy and insoluble in a solvent. Okay. Example, separation of muddy water into mud and clear water. Dissolution. Next method is dissolution. The principle of separation in dissolution is difference in solubility of the component. One of the component is soluble in a solvent, other component is insoluble. Okay, example is separation of salt and water from salt solution, or separation of sugar from water from sugar solution using dissolution. Next method is filtration. Difference in filtration, the principle of separation is that difference in solubility of the components. One of the components is insoluble in a solvent. Example is straining of tea to separate the tea leaves. And next method is evaporation. Principle of evaporation is difference in the volatility of the components. And example is separation of common salt from seawater. And magnetic separation principle is that difference in the magnetic property of the components. An example, separation of iron from the muddy gangue. And last method is crystallization. The principle of crystallization is the difference in solubility of the solid present in the liquid. Present in the liquid is solubility of the solid present in the liquid is greater, then this method is used. Crystallization. Example is rock candy or candy sugar, or crystallized sugar lumps. Okay, so these are some method of separation, and you have to remember the principle of each type of separation with the example. Okay, next day I will discuss in details about this separation mixture. Okay, thank you students.